Hello everyone. In this video, I shall discuss the solution of question number 44 of GATE Physics 2021. This is a multiple select question. A uniform block of mass capital M slides on a smooth horizontal bar. Another mass small m is connected to it by an inextensible string of length L of negligible mass and is constant to oscillate in the xy plane only. Neglect the sizes of the masses. The number of degrees of freedom of the system is 2 and the generalized coordinates are chosen as x and theta as shown in this figure. Px and p theta are the generalized momenta corresponding to x and theta respectively. Then we need to find out the correct options. Let's solve this question. The length of the string is small l and it is at an angle theta with respect to the vertical direction. In the Cartesian coordinate, the mass small m is at position x1, y1. Here x1 turns out to be x plus L sin theta and y1 turns out to be L cos theta, where x is the distance of mass capital M from the origin. The kinetic energy of the mass capital M is equal to half into capital M into x dot square, and we assume that the mass capital M is at potential energy V1 equal to 0. The kinetic energy of the mass small m is equal to half into small m into x1 dot square plus y1 dot square, and the potential energy of the mass small m is equal to minus mg y1. The Lagrangian of the system is equal to T1 plus T2 minus V1 minus V2, where T1 and T2 are the kinetic energies of the masses capital M and small m respectively, and V1 and V2 are the potential energies of the masses capital M and small m respectively. Here we put the values of T1, T2, V1 and V2. Then we obtain the Lagrangian L equal to half into capital M into x dot square plus half into small m into x1 dot square plus y1 dot square plus mg y1. Now x1 is equal to x plus L sin theta and y1 is equal to L cos theta. So x1 dot is equal to x dot plus L cos theta into theta dot, and y1 dot is equal to minus L into sin theta into theta dot. Putting the values of x1, y1, x1 dot and y1 dot in the expression of the Lagrangian, we obtain the Lagrangian L equal to half into capital M into x dot square plus half into small m into x dot plus L cos theta into theta dot whole square plus half into small m into L square into sine square theta into theta dot square plus mgl cos theta. After some simplification, this Lagrangian L can be written as half into capital M into x dot square plus half into small m into x dot square plus ml cos theta into x dot into theta dot plus half into small m into L square into theta dot square into sine square theta plus cos square theta plus mgl cos theta. Here sine square theta plus cos square theta is equal to 1. So this can be simplified to L equal to half into capital M plus small m into x dot square plus small m into L into cos theta into x dot into theta dot plus half into small m into L square into theta dot square plus mgl cos theta. Now the generalized momentum corresponding to x px is equal to del L del x dot, which turns out to be capital M plus small m into x dot plus small m into L into cos theta into theta dot. In option A, it is given that px equal to capital M plus small m into x dot plus small m into L into cos theta into theta dot. So option A is correct. The generalized moment corresponding to theta p theta is equal to del L del theta dot, which is equal to small m into L into cos theta into x dot plus small m into L square into theta dot. But in option B, it is given that p theta is equal to small m into L square into theta dot minus small m into L into cos theta into x dot. So option B is not correct. Now let's find out the equation of motion corresponding to the x coordinate, which is given by del L del x equal to ddt of del L del x dot. The Lagrangian L is independent of x, so del L del x is 0. On the other hand, del L del x dot is equal to capital M plus small m into x dot plus small m into L into cos theta into theta dot. Now px is equal to capital M plus small m into x dot plus ml cos theta into theta dot. So the equation of motion turns out to be dpx dt equal to 0. This means px is constant. In option C, we have px is conserved. So option C is correct. Now let's also calculate the equation of motion corresponding to the coordinate theta, which is given by del L del theta equal to ddt of del L del theta dot. Here del L del theta dot is equal to p theta. So the equation of motion turns out to be p theta dot equal to del L del theta. Now del L del theta is equal to minus small m into L into sin theta into x dot into theta dot minus small m into g into L into sin theta, and this is equal to p theta dot. So p theta dot is not equal to 0. This means p theta is not conserved. In option D, we have p theta is conserved. So option D is not correct. So we have found that option A and option C are correct. So in this question, option A and option C are correct.